we have seen in last class that if two junctions of thermocouple are maintained at different temperatures, then a EMF will be induced across these junctions, right? Okay. If I have different temperature at the junction, then a small EMF will be generated on the ends of this junction. This will be the configuration you will find in your lab. And you have to measure the EMF between this point X and point Y. Now, the simplest way to measure such small potential is to use potentiometer. Now, this potentiometer you must have learned in your high school or in your lower semesters. And there are various configurations of this potentiometer which can be used to find number of things. Like you can find internal resistance of a battery, you can find EMF generated by of a battery, and even you can find some small resistances using some modified forms of this potentiometer. But in this particular experiment, we will be using this potentiometer to find only the EMF generated by this thermocouple. And even I will use this potentiometer in a very basic configuration. So potentiometer is something like this. You have two ends, let's call this end A and B, and there is a wire just like a Carey Foster bridge wire, but it is of 1000 centimeters, right? The length of this potentiometer wire is 1000 centimeter. Now the basic principle of this potentiometer is, in this particular case, is if you apply a small potential on this potentiometer ends, if you apply a very small potential on this potentiometer ends, let's say B is at 0 volt and A is, you are applying A at let's say 100 millivolt. Only this much of potential on whole of this wire. Then, as you can see, the potential drop across each unit length of this potentiometer, the potential drop across each unit length of this potentiometer will be 100 divided by 1000 centimeter. As simple as that. 100 divided by 1000 milliwatt. This will be your potential drop across unit length of potentiometer. Okay, you are applying 100 millivolt on whole of the potentiometer and 100 divided by 1000, because 1000 is the total length of the 1000 centimeter is the total length of the potentiometer wire. Right now, applying such potentials, applying such 100 millivolt potential, precise 100 millivolt potential can be done by various methods. For example, Like suppose these were the ends of your potentiometer A and B, and you are using a 5-volt battery, which is very readily available. Okay. So on this 5-volt battery, what you can do is you can simply connect a resistance box, a large resistance box, and a small resistance box. And let's say the large resistance box
सर
is, yes,
सर अभी तो हम थोड़ा पोटेंशियल लगा रहे थे, अब ये 5 वोल्ट कैसे आया?
नहीं
मतलब
मैं
क्यों कर?
बता रहा हूँ कि 100 मिलीवोल्ट कैसे क्रिएट करोगे।
अच्छा अच्छा, ओके सर।
100 मिलीवोल्ट का तो सोर्स होगा नहीं ना हमारे पास लैब में।
यस सर।
तो
यस
सपोज
सर।
5 वोल्ट का सोर्स इजली है या 2 वोल्ट का सोर्स इजली होता है, ये तो मैं 5 वोल्ट से 100 वोल्ट with the help of potential divider circuit I can easily create. With the help of potential divider circuit I can easily create a small magnitude of potential for this potentiometer. So ये 5 वोल्ट है, इसको मेरे को 100 मिलीवोल्ट करना है, so that means it has to be 50. Okay, so if I consider this as 10 ohm and this as 500 ohm, let's say this is 500 ohm. Okay, so if I take connections, if I take potential drop across this resistance box and connect this resistance box to this, okay, then these were the ends of the potentiometer. In this way you will be using this type of potential divider circuit in various number of experiment in your further semesters. Okay, so in this effectively by this method what I have done is I have created a 10 divided by 510 into 5000 millivolt source. Okay, 5000 millivolt. This amount of potential will be applied on the ends of the potentiometer, and roughly I think roughly it should be around 100 millivolt if I am right. 100 divided by 500 will be, let's call this as 500, it will be 50, 50, yes, 100 millivolt, around 100 millivolt, it will be something like this. So by these type of circuitry, you can create a constant voltage source with the help of this 5-volt battery. 100 millivolt चाहिए हो, 50 millivolt चाहिए हो, 200 millivolt चाहिए हो, you can easily create with the help of this potential divider circuit. So now suppose now if we have 100 millivolts on the potentiometer ends, now here at this point I was explaining how this 100 millivolt can be created with the available resources. Okay, now you have to understand one thing. This B point is at 0 volt and this A point is 100 millivolt. Now as you move across this wire from point B towards point A, the potential will gradually increase, right? The potential will gradually increase. For example, if you connect your measuring device at this point B, and at this point, which is of 100 centimeter only, at this point, the whole wire is of 1000 centimeter, but if you measure potential between these points, at point B and at this point which is at 100 centimeter, then you will be measuring the potential as 100 divided by 1000 into 100 millivolt, right? Because in this potentiometer wire, potential is increasing step by step with the along the length of this potentiometer wire. So this potential is gradually increasing from point B to point A. Now we will take benefit of this fact that if we apply potential on this type of system, then potential will be gradually divided along the length of this wire. Now the thermocouple, the ends of the thermocouple, this X and Y, the X and Y, I will connect my X with this B. Okay. I will connect my end with this B, and from Y, I will join a galvanometer, and I will see the other end of this galvanometer will have a jockey, and at which point this was our thermocouple end, thermocouple terminals. I will say these as thermocouple terminals. Now, with the help of jockey, I will find a balance point. Now the question is, this balance point will be that point at which the length, this suppose balance point is coming to be here, BM. This point is M. Now, if you connect this galvanometer at point M, then there is a null deflection. The galvanometer is not showing any deflection. Then that means the potential drop across the section of BM length, potential drop is equal to the EMF, of thermocouple. ओके, वो जो बैलेंस कंडीशन मिली है वो तभी मिली है कि द पोटेंशियल ऑफ VXY, is equal to potential drop across BM. ओके, तो गैल्वेनोमीटर पे जो नल डिफ्लेक्शन मिलेगी, दैट नल डिफ्लेक्शन is obtained when this equation is satisfied, that the potential developed, the EMF generated across XY, that is thermocouple terminals, the EMF generated is equal to the potential drop across BM, right? And the potential across, so what we will do is we will just connect our thermocouple terminals to this X and this B, and we will find M. Okay, I will connect one of my terminals to B, and I will find this point M by tapping galvanometer at different sections of this potentiometer, and wherever I found null deflection, I will mark that point. Okay, I will measure the length from that. I will measure the length of that point from B, and with the help of that balancing length, suppose for a particular temperature T1, balancing length is coming to be, let's say, L. Okay, then at that temperature T1, the EMF generated will be equal to L divided by 1000 into 100 millivolt. As simple as that. Because suppose this balancing length L corresponds to BM section. Okay. Now the total length of potentiometer was 1000, and the applied potential on potentiometer was 100 millivolt, right? So in this section, suppose BM is anything which is L length. Okay, then the potential drop across this section BM will be equal to L divided by 1000 into 100 millivolt. So what you have to do is you have to increase the temperature of thermocouple. You have to continuously measure observe this length L, this balancing length L, and with the help of this balancing length L, you can find the EMF generated in the thermocouple. Let's say it should be something like this. Suppose your T1, your T2 is at constant, let's say 5 degree. Your T1 is 40, 50, 60, 70, 80. So your balancing length, let's say, is increasing is something like this. It's coming to be 90 centimeter. It's coming to be 115 centimeter, 140 centimeter, okay, 180 centimeter, fit 210 centimeter. Then you can easily find with the help of this balancing length 90 divided by 1000 into 100 millivolt. That means 9 millivolt is the potential generated if your balancing length is 90 centimeter. And for this balancing length, 105 divided by 1000 into 100 will be your potential EMF generated in the thermocouple at that particular temperature. So generated EMF can be calculated very easily with the help of this balancing length, and this balancing length you have to measure in the potentiometer for after obtaining a particular balance point, after obtaining a balance point at that temperature. Okay, so observing this balance length will take few seconds, either 2, 3, 4 seconds maximum, but increasing this temperature will take some time. Okay, so it is advised that you start heating this one end of this thermocouple, and with the increase in temperature you will simultaneously measure the balancing length. Okay, so with each temperature, with each difference of temperature, like after 10 degrees Celsius, after 15 degrees Celsius, you will measure this balancing length, and you can tabulate that delta T and E. After all, from these things you will find delta T, and with the help of this L you will find EMF generated. That will be your table, that will be your observation table, final observation table, and you have to plot the graph between this EMF and delta T. Okay, and on this you can see okay, इसमें directly लिखा है potential applied on potentiometer is 100 millivolt. Now maintain temperature of cold junction at 10 degrees Celsius. Okay, by uh, putting some ice cold water in this, you can easily maintain the temperature of cold junction at 10 degree. Now obtain the balance point while increasing temperature of hot junction. Okay, so if you click on this, this will directly give you temperature of cold junction is 10 degrees Celsius, temperature of hot junction is 140. So okay, temperature of hot junction is, it will start from 100 degrees Celsius. So first value of delta T will be 90 degree. Okay. So position of balance point at T is equal to 100 degrees Celsius is 300 centimeter. So can anyone tell me what will be the EMF generated at this point?
30 megavolt.
30 megavolt, millivolt.
Millivolt. Sorry,
Yes.
millivolt. 30 millivolt.
30 millivolts, because 300 divided by 1000 into 100, that will be 30 millivolt. So at this point, at this delta T, at delta T is equal to 90 degrees Celsius, 30 millivolt is being generated or being induced at the thermocouple ends. Okay, so it will be X 105 पे दिया हुआ है, 110, 115, 120, and you will see some variation, and you have to accordingly you have to calculate this EMF generated, and you have to plot this thing. Okay, back to this. So this is quite a simple experiment. इसमें आपको एक टेबल बनाना है, एक ऑब्जर्व ग्राफ बनाना है, okay. And you will see for this thermocouple thing, you will see for small temperatures, it will look like something like this. It is increasing linearly, but for large temperature differences, it will go something like this. Okay, it will go something like this. Now there are various terms which you should know. Neutral temperature, ये तो खुद भी पढ़ना चाहिए, वाइवा के क्वेश्चन है, मैं डायरेक्टली बता देता हूँ. Neutral temperature of thermocouple. Neutral temperature of thermocouple is the temperature at which the thermo EMF which is generated is maximum. Thermo EMF is maximum. So this neutral temperature is something is this. At this EMF is maximum. Temperature of inversion होता है. Temperature of inversion होता है. In this temperature of inversion, the EMF will again start decreasing. If you increase the temperature, if you increase the temperature difference further, then EMF will decrease. However, we cannot achieve those temperature differences in our lab, but yes, every potentiometer, every thermocouple will have this temperature of inversion, and after that temperature, the thermocouple effect will be reversed. It will again, the EMF will start decreasing again if you further increase the temperature. So there are various terms and there are various concepts in this thermocouple you should vary, but yes, we will only be focusing on this part of section on this section of thermocouple, in which thermo EMF generated is mostly linear, and at the towards the end of this observations you will see there is a slight decrease in rate of EMF generated at higher temperatures at delta T. This section you might observe this section, but yes, definitely for these particular temperatures you will definitely find a linear and somehow a non-linear fashion in higher temperatures. But this is a limitation of experimental conditions only. Every thermocouple will behave like this essentially. Yes.
सर टेम्परेचर ऑफ इन्वर्जन और न्यूट्रल टेम्परेचर तो सेम ही होगा ना फिर?
Yes, sir, same doubt.
Yes.
Yes, sir.
No. Temperature of inversion is the neutral temperature is at which the maximum EMF is generated. Temperature of inversion is when the direction of current will change. When the direction of current will change, and the EMF generated becomes zero.
सर तो EMF का डायरेक्शन चेंज होगा तो करंट का भी चेंज होगा ना?
Yes, of course, करंट का भी चेंज होगा. मींस ऐसा टेम्परेचर आएगा एक जिसपे आपका EMF जनरेटेड था जो डिक्रीज होने के बाद अब जीरो पे आ गया है, and if you further increase the temperature then your direction and as well as your EMF direction will change. It can again go to negative, but those temperatures are very high. 1000 डिग्री 1500 डिग्री सेल्सियस पे जाके ये टेम्परेचर ऑफ इन्वर्जन आपको मिलते हैं. Okay. So this experiment you can easily do. Now